Okay, we're going to be graphing rational equations without a calculator. I'll give a bonus point if someone can raise their hand and tell me one of the transformations that you would need to apply to this one. Actually, before I do that. Bonus point if someone can come up here. Hold on.
Way last.
Okay, different question. I'll give a bonus point if someone can come up here and graph 1 over x.
I can't do that. That's enough.
Yes. Yes. Good job.
It's really closer to the, like,
She really got that.
Oh no, exponent is Alright, so this is the graph of 1 over x. Good job, team 2. Oh my goodness, team 2 has 2 bonus points. Okay, now, looking at this. Bonus point if someone can raise your hand and give me one of the transformations. Go ahead. Up 5. So we're going up 5. Bonus point if someone can give me another transformation. Go ahead.
to the right 3.
Right 3. And there's one more in there. Vertical stretch factor of 2. Good job. Okay, so using that information, do you guys feel like you can come up with the horizontal and vertical asymptotes? Normally, the vertical asymptote is at 0, the horizontal asymptote is at 0. Can you come up with the vertical and horizontal asymptotes after the transformation? I think you guys got it. On your whiteboards, please give me the vertical and horizontal asymptotes. When you have it, hold up your board. So when you give me the asymptote, you're going to give me x equals whatever, y equals whatever. So give it to me as an equation.
I thought it was.
Yes. Can you give me the horizontal? Can you give me the horizontal?
Oh no, okay, wait.
Yes.
Oh, yeah. Sorry, I didn't.
Can you give me x equals what, y equals? You're giving me the asymptotes. Yes. You're T5, you're T6, sorry. Yes. I'm going to give you guys one more minute and then we'll go over it. Yes, but you're going to want to do x equals y equals. Yes. All right, everyone got it? You guys are awesome. So the horizontal and vertical asymptotes are y equals 5, x equals 3. Please give me the domain and range in interval notation. And the groans. Give me the domain and range in interval notation. It is not all real numbers. Neither of them are all real numbers. Because they both have asymptotes.
Bracket includes. I think it's.
Yes. Yes. Give me the range. Yes. I'll give you guys 1 more minute. Yes. Yes. Team 3, you guys close? Okay.
When did you get
Yes. All right, everyone got it? Great job. Here's the answer. So here's the domain, here's the range, and based on that information, you can graph it. So here's the vertical asymptote, here's the horizontal asymptote. You know what the graph looks like. So here we go. Hard to tell, but it's also stretched. Do you guys feel like you can do the next one? All right. So this one, you don't have to draw it on your whiteboard. I'm really just going to be looking at the graph. If your graph is right, then probably your asymptotes and domain and range are right. Okay, so call me over when someone has the graph on their paper, and I'll give you guys a point. For B. So you guys are gonna draw the graph. You can just draw it directly on your paper or on the whiteboard if you prefer. And when you have it, hold up your board. Oh, I'm sorry, don't hold up your board. Just call me over. Yeah, so do the whole thing for part B and graph it. Call me over when you have it. If you don't want to write it on your paper, because you're not sure it's right, you're welcome to write it on the whiteboard. Oh no. Okay. Yes.
Oh, does that mean has to? Wait, what does that mean? So it's like this side here. Oh, okay, wait, I can do that. Oh, wait, if I got 80 on my one, wait, how am I supposed to do that?
There's a negative. Yeah. So flips over the x-axis. All right, I'm going to give you guys 1 more minute because that was the timer.
No, I haven't done that. It's just like you just like.
Oh yeah.
Sorry?
That makes sense.
Yes. Coming.
Okay, I'm good.
It's getting serious. You don't know what that is. It's like tutoring. Nobody was ready for that one. Like, let's hear it. No one was ready. Yeah, like, no one knew it.
All right, ladies. Here is the answer. Okay, so ladies, the horizontal asymptote is at -3, the vertical asymptote is at -6, and then you have the domain and range accordingly. Please note that it's a -1, so it is reflected over the x-axis. That's why it's on this side and this side. Are you guys okay?
Yeah, we're just bonding.
All right, ladies, once you're finished copying this down, I just want to do one more example for you guys because starting with C, they get a little bit different. But I'll make a video for the rest, okay? Block C got all the way to problem F, so I'll make a video to problem F. Does anyone need a little bit more time to copy this down? Okay, I'm going to skip over to D, and I'm just going to talk about this problem, okay? And then we'll call it for the day. All right, here's D. I'm assuming all of you guys are very comfortable factoring. As people giggle. Okay, so this factors to 2 times x plus 3. This factors to x plus 3x minus 3. Remember, the places where you have zeros in the denominator, those are vertical asymptotes. Zeros in the numerator, those are x-intercepts, and any place that is a factor on top and bottom, that's a whole. So in this case, we have a vertical asymptote at x equals 3. Because once you cancel these out, you just have this on the bottom. You have a whole at x equals -3. And you can figure out what y would equal if you plug in -3 after canceling out the common factor. You end up with -1/3. So you know in the graph there's a whole at -3, -1/3. This is going to cancel out, so there is no x-intercept. Bonus point if someone can tell me how to figure out the horizontal asymptote, since transformations are kind of tricky here. Who doesn't have as many? Priority to team 3. Think about the degrees. What's the degree on top? What's the degree on the bottom? What does that mean? All right, who hasn't answered yet? You guys are...
Leah hasn't answered yet.
Yeah.
The birthday girl hasn't answered.
It's your birthday? All right, go ahead.
It's my birthday too.
Whoa.
I have my hand up longer.
Well, isn't it the degree of x?
Oh, well, I know.
Go ahead.
The degree of x on the bottom is greater than the top, so it's
Okay.
Yes. Anytime the degree on the bottom is bigger than the degree on the top, the horizontal asymptote is 0. Anytime. So if this degree is bigger than this degree, it's going to be 0. Great job.
So like, oh, you're gonna spirit.
Okay. All right, so the domain and range, please notice that the asymptotes and the whole is excluded. So we have 2 numbers excluded in both the domain and the range. All right, and there's 9 minutes left in class. I want to give you guys time to work on homework. Are there any other questions on D? Oh, because if you cancel out the x plus 3 on top and bottom, and then plug in -3, you end up with -1/3. Well, if you plug in -3 now, you get undefined, because you get a 0 in the bottom. But if you cancel this out and then plug in -3, you get -1/3. So it's undefined there, but it approaches -1/3. The homework is to finish up 4A. Yes. All right, I will leave this up here. Please feel free to work on your homework. You're welcome to get your cell phones. You guys did an outstanding job. Yes. Yeah, okay. So we know that there's a whole at -3 because that's the common factor, right? So if I want to find what is that point, you can't just plug in -3 because you're going to get undefined because you get a 0 in the bottom. But if you cancel this factor out, then you have 2 over x over 3. Or sorry, x minus 3. Then plug in negative 3. And then you get negative 1/3. Because negative 2 over 6 is negative 1 over 3. So that's how you know that even though it's undefined at that point, it approaches this. That's the answer to that question she was just asking. So you know that there's a hole at negative 3, right? Because that's the common factor. But you can't just plug in negative 3, otherwise you'll get undefined. But I want to know what y equals at that point. So if you cross out the x plus 3, you end up with 2 over x minus 3. Then plug in negative 3. And then you get 2 over negative 6, which simplifies to negative 1/3. Any other questions? Yes. What happened? Oh, you didn't turn in your packet? Yeah, let me pause this. Hold on. Alright, I'm going to cover the last 2 problems. Okay, so problem C is f of x equals x plus 1 over x minus 5. Because the degree on top and bottom are the same, you're going to divide the leading coefficients. 1 divided by 1 is 1, so we have a horizontal asymptote at y equals 1. There's a vertical asymptote at x equals 5 because that's where the denominator equals 0. There's an x-intercept at x equals negative 1 because that's where the numerator equals 0. There are no common factors between the numerator and the denominator, so there are no holes. So using the horizontal and vertical asymptote, we can figure out the domain and range as follows. And so here is the graph. And finally, we have f of x equals 2x squared minus 5x minus 12 over x squared minus 2x minus 8. First thing you're going to want to do is factor the numerator and the denominator. Sorry, the video glitched there for a second. I'm not sure where I left off, but here this is factored. There is a common factor on top and bottom, so we know that there is a hole at 4. If you cancel this out, the x minus 4, and then plug in 4, you end up with 11 over 6 for y, so the hole is at 4, 11 over 6. The horizontal asymptote, the degree on top and bottom are the same, so you're going to divide the leading coefficients. 2 divided by 1 is 2, so the horizontal asymptote is at y equals 2. The vertical asymptote, once you cancel out the x minus 4s, you're just left with x plus 2 on the bottom, so this gives you x equals negative 2 for a vertical asymptote. And then the x-intercept, that's where the numerator equals 0. After we cancel out the x minus 4, x is going to equal negative 3 over 2. So here's the x-intercept. The domain and range exclude everything. The domain and range exclude the asymptote and the hole. They include everything else. So here's the domain and here's the range. And that makes you guys all cut up with block C. Thanks so much for watching.